Hey guys, it's Mr. Kaitis. We're going to look at some linear programming problems for you guys in case you need the help with for the quiz tomorrow. Just a quick reminder of the different steps that are associated with doing this. You want to first and foremost, with all of your conditions that need to be graphed, you want to make sure you put them to y equals mx plus b format. Once they're there, you want to graph the inequalities, and it's really important that you remember to shade them. Shading is going to be what shows us where our feasible region and solution is. Once you find the shading and you find where they overlap, you'll want to find the corners of the shape, and we'll look at that more in a moment. And then last but certainly not least, you're going to want to optimize it, which really just means finding the minimum or the maximum. And to do that, we'll take our corners and plug them into the correct function. Let's take a look at an example problem. So for this problem, we have three major constraints. X plus y is less than or equal to 7 is our first constraint. Our second will be x is greater than or equal to 0. And our third will be y greater than or equal to 0. A quick star note for you is that when you're dealing with the x and the y conditions, I know a few people were confused. It's really important to remember that when you're dealing with an x condition, you're going to be using a vertical line. And we'll talk about that as we sort of graph out this problem. When you're working with a y conditional, you'll want to use a horizontal line. And again, we'll look at that here as well, just to give everybody a little taste of what's going on. And we can follow the steps pretty directly. We said our first part, where we put everything into y equals mx plus b mode. So we'll start that here. We have our x plus y, and apparently we need to calibrate, so hold on one moment. Sorry about that. That should be a little bit better now. Okay, so we're going to be dealing with x plus y is less than or equal to 7. To put this into y equals mx plus b format, all we have to do is subtract by x. And that should make this pretty easy to graph. Now I know that I write the negative x first, just because that's how I was taught, and it puts it and makes it look like y equals mx plus b. It doesn't matter whether you put that or 7 minus x. But let's go ahead and graph this. We'll do this one in red. So we want to make sure to put our y-intercept at 7. And then we'll notice that our slope is -1, so we'll go down 1 and over 1. Once we have our 2 points, just like before, and during class, we'll go ahead and graph the line to make it nice and straight. And we'll extend that in both directions. We also have to remember that it's important we test a point. So let's go ahead and plug in 0, 0. And we can evaluate from there. We know that 0 always cancels the negative. And we're left with 0 is less than or equal to 7. I'm going to say that that's almost certainly true, otherwise we have some issues. I'm going to go ahead and shade right over the 0, straight downwards. Just like we did when we did systems of inequalities and when we did just straight inequality graphing a couple weeks ago. Now the only thing left that I have to deal with here is my x greater than 0 and my y greater than 0 conditional. And then I'm in pretty good shape. So the basic idea of what's going on here is I need to find all the places where these two conditions are satisfied. All right? So let's take a look at this. If I were to graph x equals 0, we said that that was a vertical line. So let's put that vertical line right here. This is my x equals 0 line. Okay? So x is going to be greater than or equal to 0. And when we think about the x values, what we can think about is the fact that x gets bigger as we go to the right. So if we're looking at going towards the right, it's going to be bigger in this area, the area that we're shading. Keep in mind for the x values, I don't really care whether I'm going up or down. It's only important to note that my line needs to make sure that my x's don't change. That's why it becomes vertical. It's a little backwards. You normally expect the x to be horizontal. If we look at a similar setup for the y condition, the y's will always be vertical because I can't change my up and my down. So my y greater than or equal to 0 is going to be based off of this line, which hopefully you can see. And again, if I think about going up or down, it's going to be bigger. So remember, we're dealing with y greater than or equal to 0 if I'm shading upwards. Okay. So what we can sort of notice here pretty directly is that there's only one spot where all three of these lines sort of cross at the same time. And the place that they cross is right here in the middle. This is where all three of them cross at the same time. Okay? So I'll go ahead and highlight that for you. We have all the red, the blue, and the green lines in this area. Okay? So our goal here then is to try and find, step 3 is find our corners. What I mean by our corners are points like this one. Okay? Points where the actual equations in that feasible region, that shaded area, comes to an end. We want to find those coordinates. So that one looks like it's at 1, 2, 3, 4, 5, 6, 7, comma 0. So that's one of our 3. I'll put that up here. 7, comma 0. The second one looks like it's right at the origin. And our third one is that y-intercept for our function, like right here, that guy. And he looks like he's at 1, 2, 3, 4, 5, 6, 7, so 0, comma 7. Those are our 3 corners. All that's left is to plug those corners into the optimization equation, and we can find our min and our max. I'm just going to make a little bit of room here. We can do that pretty directly. So, for our optimization, we'll get z equals 3 times 7 plus 0. Z equals 3 times 0 plus 0. And z equals 3 times 0 plus 7. Remember, we're just plugging it directly into that optimization equation. That one right up here is what we're using when we're down here. And if we find each answer, we'll find that 3 and 7 is 21, 0 and 0 is just 0, and 3 times 0 plus 7 is 7. We'll find our max is 21, and our minimum is 7. As noted, you want to try and find whichever of those it is that the problem is looking for. Sometimes it'll be the min, and sometimes it'll be the max. If you have any questions, you can go ahead and throw me an email. If not, we'll see you tomorrow. Have a good evening.